So before we get started in our new topics for this section, we want to do a little bit of review of something that we've heard of, but it's been a little bit a long time, maybe middle school since you've seen it, and that's scientific notation. Hopefully this kind of sparks some memory in you guys. So scientific notation are numbers that are either really, really big or really, really small. Things that scientists might use in real life. Like scientists might be measuring the distance to the sun. That's really big. Or maybe the width of a cell, that's really, really tiny. So they are things that happen in real life with scientists, and that's how we get the name scientific notation. Now, scientific notation is given to us like down here in example 2. That is scientific notation. Our calculator is going to give an answer a lot of times in these sections in scientific notation. But MyMathLab is going to want them in standard notation. And standard notation is what we see written up here in example 1. So we've got to learn how to read it from our calculator and write it in standard notation. There are a few times that MyMathLab is going to let us leave our answer in scientific notation, so just be on the lookout for those. But in general, almost all the time, we're going to write our answer in that standard notation. So let's practice example 2 here. Now, if you notice, in A and B, one has a positive exponent and one has a negative exponent. Think about just a regular number line. Back in the day, nothing fancy here. Positive numbers were to the right, negative numbers were to the left. We're going to keep that in our mind here. So I have a positive exponent of 6. So that means I'm going to move my decimal to the right, the positive side, 6 times. 1, 2, 3, 4, 5, 6. And I'm going to fill in all those other spaces with zeros. So 1, 2, 3, 4, 5. So my answer gets to be 5,200,000. So that is the standard notation. For this next one, it's got a negative 6 in the exponent, so I'm going to go to the left because it's negative. And again, filling in with zeros as I go. So I'll move one space, 2, 3, 4, 5, 6. Do note that there wasn't a decimal there, so I knew it went right after 7. 7 is the same thing as 7.0. You can always just put that decimal out there. We usually don't because we're lazy, so we don't want to write it, but technically that's the same thing. So 1, 2, 3, 4, 5, and then 0.7. So that is the standard notation. Now, depending on the model calculator you have, most of them, not all of them, but most of them are not going to use a 10. Instead, they would have written this as 7e to the negative 6. That's just because they don't have a very good operating system. Some of the newer ones can actually put a 10 with a little exponent up there. The older ones cannot. So that e means exponent. So the negative 6 is in the exponent. So our calculator would give us this answer, and we would type in the other with all the decimal and all the zeros into MyMathLab. Let's go back and try example 1. So this was given in standard notation, and I want to write it in scientific. So there's no decimal in this first one, so I'm going to put it all the way over here, and I'm going to count how many loops I have. Let me zoom in just a little bit. 1, 2, 3, 4, 5, 6, 7, 8. So that would be 2.5 times 10 to the 8th. This was a big number, really large, so it's going to be a positive exponent. And the decimal place always has to be in between those two numbers. You can only have one number to the left-hand side. Or another way to think about it is you can only have something in the ones place. We couldn't have 25 times 10 to the 7th. It has to be 2.5. We have to have one number in the ones place, nothing in the tens place. And then for B, I do see my decimal place here. Again, I'm trying to get one number. So I'm going to stop right after 1.25. I can't do 12.5. I can't do 125. Just a number in the one spot. This was a really, really tiny number. So I'm going to use those negative exponents on this one.